Okay, project 4. We've heated our refractory model in the oven for 10 minutes and sprayed it with a model hardener and then let it cool off to the touch. Inspect the refractory model for any deficiencies or inadequacies from the duplication. Make sure that it's exactly as the master model. Now, my first step, as has been in the previous projects, I'm going to start by free-flowing wax. And I'm using the pattern wax. I'm not using inlay wax. It's consistent with the whole pattern. Burns out a lot easier, quicker, faster. Remember the horizontal shoe extensions. Now, I'm waxing the bead line. And I may go slightly outside the bead line. And I will adjust that in the trimming. I mean, if there's any, I guess, calm times during cast partial denture fabrication, it would be the wax up. It's pretty frenetic most of the time. Models, duplication, refractories, burnout, sandblasting, casting. I mean, that's a lot of production. So I'm going to put an even thickness of wax for the palette. And then what I'll do, as I've done in the other paletal strap and horseshoe design, is I'll thicken up the center slightly, like a ridge, to kind of give it some strength, but not noticeable that it's like a big lump in the framework. So after I've heated my spatula, I've heated wax, an even thickness, I'll get my alcohol torch and gently, carefully, even it out. Make sure it adheres to the model exactly. I've filled in the gingival margins of the aprons on the canines. I've made sure I filled up all the bead lines with wax, even gone a little bit extra just to make sure. The last thing I want to be is short. And then I'm going to, from one side to the other, create a slight elevation. This will give it some strength. And you can see that darker section. It's like a belt of wax. And then what happens, I need to blend it in on the anterior and posterior part of that. Blend it into the palatal layer of wax. It's not to be obvious. And you can see it's just slightly darker. You can see that darker shadow. My next step, and these are pretty much standard steps in order of operations for waxing of the pattern. Make sure, again, the mesh, you don't have it upside down. There's the flat side that comes on the pattern wax sheet or papered sheet. Make sure you have a sharp, in this case I'm using a number 11 Bard Parker or surgical knife. I find this works probably best than some other shapes of surgical blades. Surgerize, remove the excess. Make sure it's sitting down just above. There's a bit of a play in this one. Well, that kind of bothers me. So, I have my backup. Sorry if I was off the screen there. Let me re-establish the working area here. I'm trimming it right at the internal finishing line. Okay, so I've got the right size, the right location, just equal to just past the ridge height. Estimating where those denture teeth are gonna go. Looks like 4, 5, 6, and 4 and 5 on the other side. And then I'm going to seal now. Maybe even at the same time thicken my horizontal shoe extensions. So now I am sealing at the internal finishing line and at the horizontal shoe extensions with pattern wax to the mesh lattice retention wax. Next step is the cast clasps. Acres. I'll start right at the rest position. I'll use the thickest part of the pattern on my ledge and finish at the line angle of the distal proximal surface, lingual and occlusal, right at the point angle. On top of the ledge they've created. A little bit long. I'll take that off. And now that is adhered to the molar, the first thing I'm going to do, or the only thing I'm going to do left, is fill in the rest position. Once I grab some wax here, I'm working around the camera. So I had heated my spatula in midair, not anywhere near the flame. Seal the shoulders. Maintain the thickness of the guide plane roughly to the thickness of the clasps. Very careful. Use magnification to clean up your wax up if you've made a slop. I mean, I've seen many people take so painstaking care making a full contour molar, and then only to be cavalier with chromium cobalt partial framework. It doesn't make sense to me because this is a lot bigger than a crown and a lot more trimming and just as exacting. On the ledge to the point angle, I'll use my nail to kind of snip off the rest. I'll use this instrument to push it against the model. If you have the back end of an eraser, you can use that instrument as well. And then again, the rest, inlay rest, music occlusal, nice and hot, make sure it's completely filled in, and then seal the shoulders of the clasp at the same height. This is, I think, the difference between the first few you've made and some errors you've made is where that clasp, the super bulge clasp, originates from the occlusion, whether it's the buccal or lingual clasp. And I made this guide plane in wax the same thickness as the clasp. Now, on 1-3 and 2-3, we're going to bend some stainless steel wires and solder them to the framework when we're done. If we were to do a titanium wrought wire clasp, which I'll do an example on one side, Therefore, if you choose it, we could do it on both. We would bend the wire and include it in the wax up. Titanium can withstand high temperature. Although, like if we go back to week 1, was created as part of the titanium cast system, which was a low temperature gypsum based investment, not the high heat phosphate based investments. And then what happened is Titanium, which was Austinol, I believe, out of Chicago, was sold to CMP, which is Nobilium out of Albany. And then the only thing they've kept is the wire. And I think facetiously, if I can say, if that's the right word, it's because people keep buying it. But really, what happens is we have to go to metallurgy class. Once we put something like this up to 18 degrees, it doesn't melt, doesn't disintegrate, doesn't disappear, but it definitely gets heat treated, losing its modulus of elasticity, and then losing its memory. So really a wrought wire clasp or stainless steel clasp or platinum gold palladium would be more advantageous. Now I'm looking at my master model beside me here. I saw where I measured 0.75 of the undercut. And now I'm bending a wrought wire clasp as I would in my acrylic partials. But I gotta be really careful though. This is expensive as well. I don't need to cut off a whole section. I probably was a little bit over exuberant cutting this piece. And then I'm gonna hide it as part of my I'm part of my external finishing line. The words are difficult these days. The titanium will be part of the external finishing line. I'll hide it. And hopefully you won't notice. And I'll show you how that goes for one side. And if we choose, we may do both. But I would like to do the stainless steel so we can laser weld and get our experience with the laser welder. But we only have so many projects to experience so many procedures with. So as you can see, this titanium wire now will be embedded in wax and will be part of my external finishing line if I hide it there. I'm not exactly 100% satisfied with the guide plane, so I'm going to get a little bit tighter to the guide plane and I'll lift it up off the mesh retention a bit. We'll turn that corner a little sharper. There we go. Just bend this section down a little bit. And there we have our titanium wrought wire clasp on the left side, on tooth number 13, as part of the external finishing line, which I'll hide it. And once I put the finishing line wax on top, I'll wrap it in inlay wax. And what happens with titanium, it withstands the heat, gets heat treated, unfortunately, but will adhere mechanically to the molten chromium cobalt through the casting process. Well, I should have checked it a little bit more. I'm going to go this way here. There we go. We'll make this finishing a little bit thicker. That brings us to our next procedure. Which is the external finishing line, which comes straight down the guide plane at the same angle of the tooth, just on top of our internal finishing line. I'll do both sides at the same time. This one I'll do right on top of my Ticonium, which will just sit just inside. Now, as we've done before, we'll take our pattern wax and seal the finishing line wax to the palette, only on the palatal side, leaving this nice sharp line. That'll represent our junction line or external finishing line between the acrylic and the palatal pattern. Steady hand during this procedure. Just fill in a little void here. I feel in the thickness of my shoe extension on that one connection was a little on the weak side, as well as under the Ticonium wire. I can use a little alcohol torch here. Be very careful as not to ruin the integrity of the 22 gauge wax that's representative of the external finishing line. I'll bring in my 0.6 millimeter stippling wax. It's the final procedure here. I'm gonna just cut a little bit of it at the back to kind of fold it over, so I don't have to stretch it as much to get it into place. I don't want to like make it any thinner than it already is. I want to maintain the thickness and gently, ever so gently, maintain the integrity of the stipple pattern, and then slowly ease it into place. Now, I didn't have much wax as a cingulum on the canines. Pretty much that'll be 0.6. The patient isn't missing canines. I'm just making a little apron rest. That was the bent one. You can heat up the edge of your blade and remove the excess stippling wax. Now here I'm going to, on an angle, cut the 22 gauge wax and the stipple pattern wax at the same time, sealing them together, creating that nice sharp external finishing line. Slightly behind the bead line. I mean, a little bit longer is better than short, just slightly behind, because I'll use that 0.6 pattern wax to probably seal it. Again, on an angle, surgerizing the 20 gauge wax. Gotta be careful here with the Ticonium wire is. Now, you can still see the Ticonium wire transparently through here, but once acrylic's on there and cast it, it'll all become one. Now, you won't see it. There's two pieces there. Now, the last step, very important one, every step's an important one, is to seal the major connector stippled pattern 100%. Any investment gets underneath this, it'll be ruined. So I'm sealing this to the refractory model, sealing it down very neatly, possibly slightly behind the bead line just to ensure. It was just lifted there. I'm going to fill it in just to ensure that I have my bead line covered. I mean, don't go like 5 millimeters behind it, but a millimeter beyond is fine. And nice and neat, easy to trim, very thin to trim with your thick disc. You'll be trimming up to the bead line. Another critical area is this apron. Not too thick. Here we go. So I've done one Ticonium wire on one side, and I'm going to do a stainless steel wire. I'm going to bend it after the fact and laser weld it. I think for the our program here, we'll probably do the stainless steel wire and do the laser welding, which I think is an important skill to practice for this project. And I'm not sure if we can get this far in one day, but we're going to attempt to keep moving in that direction. Now, I'm going to get my Zale carver, and under magnification, I'll go around and sharpen up these extensions where I've sealed if I've gone a little too long. Sharpen up the apron especially, nice and crisp. Sharpen up the guide plane. Remove any excess mesh that's over the ridge. Shape the rests and the guide planes. Here I'm a little short. I'm going to add a little bit more there. You can put a little concavity in now, and then crisply clean up the shoulder as I've just done, as well as on the other side, because the clasp comes up to the rest, originates from the rest, whether it's reciprocal or retentive. Originates from the rest, the super bulge clasp. The reciprocal arm will stay above the height of contour. The retentive arm will then traverse below the height of contour in the terminal third. But at the guide plane, it originates up high, marginal ridge height, around the rest. You can see I just added some shoulder here to number 1/6, and now I'm going to relieve slightly. I can shape it. It's a lot easier in wax. And then there's just a little excess there. Now, completed. We would take a sprue now, and you could probably do it in one sprue, but I think let's try one here and one here, and we will do this with 2 sprues. We can do it with the rectangular sprue or the round sprue. We can, it doesn't matter. Thank you.